Hello, welcome to Mastering Statistics. We're going to cover in the realm of regression analysis the concept of what we call a prediction interval. This is actually the first topic that you get to in regression. I think that's really difficult to truly understand. It's not because it's hard. I promise you in 10 minutes it'll be really easy for you. But the problem is that it introduces some ideas. It's just really easy to get confused as to what they're actually talking about. So we're going to take it step by step, and we're going to start by looking at this simple graph that I've drawn here. But I'm going to warn you, I've got to talk a lot, and I'm probably going to write a lot more than usual here, and I hate that, but I have to do it. But at the end of it, you're going to understand exactly what a prediction interval is. All right, so here's a basic regression line for some data. The example I want to keep in your mind as we talk about it is the age of a house versus how many repairs per year that house has. It stands to reason that probably young homes have smaller number of repairs per year required, and the 20-year-old homes out here have much higher amount of repairs per year. We're not saying that one causes the other, it's just saying it's something I would probably expect to have happen. Now, I want to ask you, first of all, what do we have here? We have the raw data. This is the age of the house versus how many repairs a year that we have. We have this different data here. And then through that, we calculate the equation of the regression line, and we write the regression line down. And don't forget, what does the regression line look like? As an equation, it's y hat is equal to b naught, which is the y-intercept of this line, plus b1, which is the slope of this line, times x. Now, the whole point of regression, it's really important for you to understand what is the point, okay? You see, we've sampled this data. We know what this data is. We have, what, maybe 10 points here or something like that? I haven't really counted them up, but there's a handful of points that we've collected, maybe in our block or our city that we're studying. And we know what the repairs per year of these points are, right? And from that, we draw a line through there, and we say, yeah, this is a pretty good line that goes through there. And we label it y hat. You might have been thinking, why did we label it y hat a long time ago? Why didn't we just call it y? It's basically because y hat is a sample statistic. Remember a long time ago we talked about, standard deviation and variance and things like that. And we said, for instance, the standard deviation, let's talk about the standard deviation, for the population was sigma, right? But this was a population parameter. But when we did our calculations, we calculated the standard deviation, which was S, right? These are basically, the two ideas are basically the same. It's just that when we calculate using small sample sizes or sample data of any kind, we use the letter S to tell us that, remind us that we're just talking about a small subset, maybe 100 people or 500 people. But in statistics, the entire point of it is to take samples and figure out how we can draw conclusions about the population. So the population standard deviation is called sigma. We never know what that is because we can't sample 300 million people in the country. It would take too much time and money. But we take a look at the sample standard deviation and we try to link it and try to draw conclusions back to the population standard deviation. It's the same exact thing here. This regression line goes through the data, but it's a sample statistic because this entire equation, this entire regression equation, this B0 and B1, it was calculated just from these handful of data points, right? So when we label it y hat, we're just reminding you that, hey, this regression line comes from the sample data. If I were to do this whole process again and ask 10 different homeowners with different age homes how many repairs per year they have, then I would get different answers, very slightly different answers for all these data points, and I would then calculate a different regression line. It hopefully would be pretty close to the one that I have here, but it would be different. What if I go to a different city, like somewhere in Florida instead of somewhere in Colorado? I'm going to probably expect different values for these points in time.